In this video, we're going to derive the law of cosines. So we'll start with a generic non-right triangle and draw a height from angle C to its opposite side. A height will be a perpendicular line, so it's going to intersect side C at a 90-degree angle. We'll call it H for height. Alright, by doing this, we have created two different right triangles. One that involves angle A. I'll draw that one in red. And one that involves angle B, and I'll draw that in blue. Both of these triangles involve or have side H. Okay, we're going to use these two right triangles to get the information we need to derive the law of cosines. We'll start on the red triangle on the left. Actually, before we do that, we do need to do one last thing to this triangle. For the law of cosines, we're going to need to use side C. Side C, so this side that's represented down here. Let me get a little bit do a bit of a better job with that. I'll relabel it down here, put my nice big C down there. So that whole side length, just hide that one. I'm not trying to change the information, but just communicate it differently. The sum of the red stick and the blue stick there at the bottom of this triangle add up to C. And so what we could do is we could break that length down into two pieces so that we have representations for the side length in the red triangle and the blue triangle. I'll go ahead and kind of arbitrarily choose to call this little red segment X. And since the entire length is C units long, the blue part of that segment must be C minus X. So that when you add the blue piece and the red piece together, you get C, the length of the entire piece. Okay, now we'll start by using the red triangle to get some information about these elements we've drawn in the triangle. In fact, what we're going to do is try to just get expressions for H and X, these new symbols we've kind of artificially introduced to the problem. We'll use the red triangle to get some expressions involving X and H. Okay, so the first thing we'll do is we will get the cosine of angle A. Hopefully not too surprising that cosine will come up. We're trying to derive the law of cosines, and this is where cosine comes into play. When we try to find the cosine of angle A, in a right triangle, cosine can be found by comparing the adjacent side, X, with the hypotenuse of the triangle, which is B. And to get us prepared for future steps, let's go ahead and just solve this little equation for X. If I multiply both sides by B, I can cancel the B's on that are near the X and isolate X and get X as being B cosine A. Okay, another thing that we're going to do with that red triangle is we'll go ahead and apply the Pythagorean formula to the red triangle. So the Pythagorean formula tells us that the sum of the squares of the shorter side, so that would be x squared and h squared, and we want to sum those, add those up, that will be equal to the square of the hypotenuse, which is b in this case. And we'll go ahead and get us prepared for future steps by isolating h squared here. If we subtract x squared from both sides, this will be a bit, I've got that backwards. It'll be b squared minus x squared. So these two equations, this expression for x and this expression for h squared, will prove useful later. All right, now we'll go on to the blue triangle. And we'll start by applying the Pythagorean theorem to the right triangle. And according to Pythagoras, the sum of the squares of the shorter sides, so that will be c minus x squared and h squared, those will be equal to the square of the hypotenuse, which in this case is a. Let me tidy this up a little bit so it's a little more clear. Okay, so now we'll just play with this equation until we end up getting the law of cosines. So the first thing we'll do is we'll go ahead and square c minus x. The square of a binomial like this always works in the same way. We always get a square of the first expression, so we'll get the square of c. We'll also always get the square of the last expression, x, so we'll also get an x squared term. And we'll also get twice the product of c and x. And then we'll copy this h squared back down. A little bit jammed up in there, lost my space. Now in the next step, what we can do is go ahead and replace this expression here, h squared, with what we learned that h squared equals. So I'll make the substitution. Just rewrite all of these terms. Instead of h squared, I'll write b squared minus x squared, since that's what h squared equals. Now when you step back and look at this, you'll see that we have a positive x squared and a negative x squared in this expression. So they're going to go ahead and cancel in our subsequent step. And now in our next step, what we'll do is get rid of that x. And what we learned above was that this symbol x is equal to b cosine a. B cosine a. So let's go ahead and make that substitution. Okay, sorry, I was going to color code this. And that right there is the law of cosines. I'll go ahead and do a little bit of tidying up in our last step. We usually combine the c squared and the plus b squared and put those next to each other. And we usually commute this multiplication, kind of write it in alphabetical order as bc. And so I'll go ahead and just do those little things. And we get the a squared equals b squared plus c squared minus twice b c cosine a. And this here is the famous law of cosines.